Today I will be teaching you guys how to do problem AB 2014 number 4. The problem reads, train A runs back and forth on an east-west section of railroad track. Train A's velocity measured in meters per minute is given by the differentiable function v sub a of t, where time t is measured in minutes. Selected values of v sub a of t are given in the table below. Part A reads, find the average acceleration of train A over the interval 2 to 8. Part A is pretty straightforward because all it is asking you to do is find the slope between v sub a of 8 and v sub a of 2, since acceleration is the derivative of velocity. And the way you find the slope between 2 points is you take v sub a of 8 minus v sub a of 2 over 8 minus 2. And you get negative 120 minus 100 over 6, which simplifies down to negative 110 over 3, and you cannot forget your units, meters per minute squared. Part B reads, does the data in the table support the conclusion that train A's velocity is negative 100 meters at some point in time of t on the interval 5 to 8? Since the problem states that the velocity of the train A is given by a differentiable equation, we can use intermediate value theorem to show that there is a time t on the interval 5 to 8 such that the velocity is negative 100. And if you look back at the table, 5 has a velocity of 40 and 8 has a velocity of negative 120. Since the function is differentiable, which means it's also continuous, somewhere between 40 and negative 120 is negative 100 meters per minute. Part C states at t equals 2, train A's position is 300 meters east of the origin station and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time equals 12. Use trapezoidal sum with 3 subintervals to approximate the position at time equals 12. There's a couple things you need to know when you're doing part C. You need to know that the antiderivative of velocity is position, and you also need to know how to do trapezoidal sum. The position at time 12, or 12 minutes, of train A is equal to the position of train A at time equals 2 minutes, which is given to us in part C, which is 300 meters, plus the integral from 2 to 12 velocity of train A at time t, d of t, which is equal to 300 plus the integral from 2 to 12 velocity of train A with reference to t, d of t. Now, since we don't know the actual equation of v sub a of t, but we do have a table, we get to use trapezoidal sum to find the integral from 2 to 12 v sub a of t d of t. And that would be as follows: 3 times 100 plus 40 over 2 plus 3 times 40 minus 120 over 2 plus 4 times negative 120 minus 150 over 2, which all equals to negative 450. And when you go to find the position of train A at time equals 12, you cannot forget that it starts at 300, since we are starting at the position of train A at time equals 2 minutes. So for your final answer, you get the position of train A at time equals 12 is approximately 300 minus 450, which is negative 150. So the position of train A at time equals 12 minutes is approximately 150 meters west of the origin station. You have to say approximately because trapezoidal sum is an approximation of the table given in the problem. Part D is where the problem gets really interesting. Part D reads, a second train, train B, travels north from the origin station at time t The velocity of the train B is given by the equation v sub b of t equals 5t squared plus 60t plus 25. And at time equals 2, the train is 400 meters north of the origin station. Find the rate in meters per minute at which the distance between train A and train B is changing at time equals 2. Mainly in part D, you're going to need to know how to do implicit differentiation. To make this problem easier, I drew a visual triangle to show that train B is traveling in a different direction than train A, and the hypotenuse, or the distance in between them, is represented by Z. Train B's position is represented by Y, and train A's position is represented by X. So we have a formula, Z squared equals X squared plus Y squared. And we're going to take the derivative of that formula, which is 2Z dz over dt equals 2x dx over dt plus 2y dy over dt. The information given to us before at time equals 2 is x equals 300, y equals 300, or the position of train B at time equals 2 equals 400, and the position of train A at time equals 2 is 300. And this is a 3, 4, 5 triangle, as we learned in geometry, so we know that z equals 500, because if this was 3 and this was 4, this would be 5, but this is 300, this is 400, so this is 500. And then you take the equation for v sub b of t, and you plug in 2, and you get negative 20 plus 120 plus 25, which equals 125, which is the velocity of train B at time equals 2. So first, you make it a little easier on yourself, and you divide the 2 on both sides to get rid of it, and you end up with z dz over dt equals x dx over dt plus y dy over dt, and then you plug in what you know, and you end up getting 500 dz over dt equals 300 times 100 plus 400 times 125. And from there, you get 500 dz over dt equals 80,000. And then you want to get dz over dt by itself, so you divide 500 from both sides, and you're left with dz over dt equals 80,000 divided by 500, which equals 160, and you cannot forget your meters, so it's 160 meters per minute. If you were to look back at the first 3 parts of the problem, you got 1 point for answering all of part A right. In part B, you get 1 point for knowing that negative 100 was a value in between the velocity of train A at time equals 8 and the velocity of train A at time equals 5. And you got 1 point for using intermediate value theorem to prove that you knew negative 100 was one of those values. In part C, you got 1 point for using the position expression, which was this nasty little thing right here. You got 1 point using trapezoidal sum, which is my worst enemy, all right here. And that is, and you got 1 point for the position at time equals 12, which is basically your final answer of 150. Part D was worth a whole total of 3 points. You got 2 points for using implicit differentiation, probably 1 point just for showing that you're going to use implicit differentiation, and then another point for doing the entire thing right, and then 1 little point for having your final answer with units. Overall, AB 2014 number 4 is a fairly easy problem and had an average of about 4 points on the AP test. It should be pretty basic for most of us students who have had Mr. Clinton as a teacher, maybe not Miss Collins. But that's about it. A procrastinator like me, you could have been enjoying this beautiful view instead of having to do this calculus project on a Saturday. This is Ryan from San Diego, signing out.